Bismillahirrahmanirrahim. Dear student, Assalamu alaikum. It's me, Dr. Mansoor Khan, Assistant Professor, Department of Chemistry, Kohat University of Science and Technology. The course which is assigned to me is Environmental Chemistry 2 with a course code CHEM362. Today I am going to deliver 11th lecture which is based on nuclear chemistry. This slide shows the outline of today's lecture, which will cover a brief history of nuclear energy, mass and energy interconversion, and nuclear fission reaction. Now, the first one is history of nuclear energy. Nuclear energy was first discovered by Enrico Fermi in 1934. The first nuclear bomb were built in 1945 as a result of the infamous Manhattan Project. The first plutonium bomb, codenamed Trinity, was detonated on July 16, 1945 in New Mexico. In August 6, 1945, the first uranium bomb was detonated over Hiroshima in World War II. 3 days later, a plutonium bomb was dropped on Nagasaki. At this time, the nuclear energy was only used for warfare because it was the time of World War II. There is over 200,000 deaths associated with these two detonations. Electricity wasn't produced with nuclear energy until 1945. This is the source from where the history of the nuclear energy was taken. Before directly going to the nuclear energy, first the relationship between mass and energy is of immense importance. In this slide, we will discuss the relationship between mass and energy. The famous scientist Einstein suggested that mass and energy are related by any famous equation, which is E is equal to mc square, where E is energy, m is mass, and c is the velocity of light. So this equation shows that a small amount of energy, a small amount of mass, when converted, a small amount of mass can be converted into a huge amount of energy. This was basically the basis for the nuclear energy. Converting the mass of 1 penny could resolve the energy problem of 100 men for 1 year. So this is a very huge amount of energy. That's worth $3 million of electricity. This is called the law of conservation of mass and energy. So after this energy, people were looking for nuclear energy because immense amount of energy can be produced by using this nuclear energy. Electricity generations. Electricity can be generated from the nuclear energy by two methods. One is the famous nuclear fission reaction, and the second one is the nuclear fusion reaction. But in this lecture, we will only discuss about the nuclear fission reaction because the fusion reaction is not into consideration. So, what is nuclear fission reaction? It can be divided. The nuclei of heavy atom are split into smaller nuclei, which is also called daughter nuclei, under the bombardment of neutrons. This is the image that shows that how the nuclear fission reaction can take place. A nuclei, a neutron comes and collide with a very heavy nuclei. After that, the nuclei turns into its transition state. After the transition state, the nuclei is split up into two smaller nuclei, which is called the daughter nuclei, along with the emission of immense amount of energy and also the neutron. The released neutron is further collide with other nuclei and produce another daughter nuclei, and the chain reaction is started that is used for two purposes: for warfares and also for electricity generation. Now, the nuclear fuel cycle is very important because it will show us that how the uranium can be used for electricity generation. So the first step in nuclear fuel cycle is mining. Third one is conversion. Fourth, enrichment. Fifth, fuel fabrication. And the last one is nuclear power reactors. After the enrichment, the uranium can be used for two purposes: for nuclear power plants and also for nuclear power program for producing the bomb. So the first one is mining. Uranium ore is usually located early. Samples are then drilled and analyzed by geologists. The uranium ore is extracted by drilling and blasting. Mines can be either open air pits or underground. Uranium concentration are small percentage of the rock that is mined. The second step is milling and leaching. The ore is first crushed into smaller bits. The bits sent through a ball mill where it is crushed into a fine powder. The fine ore is mixed with the water and thickened. The ore is then leached with help of 90% sulfuric acid of uranium ore, which the ore is then leached with sulfuric acid, which leach 90% of the uranium from the ore. Uranium ore is separated from the depleted ore in the multi-stage washing system. The depleted ore is then neutralized with lime and put into a tailing repository. This is the images which shows that how the milling and leaching takes place. Yellow cake, a terminology which is often used during the nuclear fuel cycle, is a yellow cake, which is a very important stage during the production of uranium. The uranium solution is filtered and then goes through a solvent extraction process. Kerosene and ammonia solution are largely used for purification of uranium solution. After purification, the uranium is put into precipitation tanks. The final product is known as yellow cake. This slide shows that how the yellow cake can be produced. The third stage is transportation. Yellow cake is heated to 800 degrees centigrade, which make a dark green powder, which is 98% uranium oxide. The dark green powder is put into 200-liter drums and shipped overseas to fuel nuclear power plants. These are the drums which are used for transportation. Mostly the transportation takes place by the help of large ships. The fourth stage is conversion. To enrich uranium, it must be in the gas form, which is uranium hexafluoride. First, the yellow cake is converted to uranium dioxide through a heating process. Then anhydrous hydrofluoric acid is used to make uranium tetrafluoride. Next, the uranium tetrafluoride is mixed with fluorine gas to make uranium hexafluoride. This liquid is stored in steel drums and crystallized. Another step during the nuclear fuel cycle which is very important, is uranium enrichment. Uranium enrichment increases the amount of uranium-235 in comparison to uranium-238. It means that if we increase the concentration of uranium-235 in the ore instead of uranium-238, this process is called enrichment. It is the most difficult and the dangerous process during the uranium processes, because uranium-235 is radioactive. Domestic power plant use a mixture that is 2 to 5% uranium-235, which consists 2 to 5% uranium-235. Highly enriched uranium is generally used for weapon, some research facilities, and naval reactors. The conversion and enrichment process release uranium hexafluoride, which is radioactive and chemically toxic. Uranium hexafluoride produce another toxic chemical called hydrofluoric acid when come in contact with moisture. Hydrofluoric acid, the most strongest solvent on the earth. There have been numerous accidents during the conversion and enrichment processes. Depleted uranium is the waste that is generated from enrichment process. The fifth one is transportation. The uranium materials are transported from mining location to conversion locations. Then from the conversion location to the enrichment locations. Then from the enrichment location to the fuel fabrication facilities, and then finally to the power plants. The materials are transported in special container by specialized transport companies, because most of these materials are radioactive in nature and also chemically toxic in nature. In US, Asia and Europe, the transportation is mainly by train. The fifth stage is fuel fabrication. The uranium hexafluoride is taken to a fuel fabrication facility that process the powder into small pellets. The pellets are put into long tubes called mu rods. A fuel assembly is a cluster of these seal rods. It takes approximately 25 tons of fuel to power 1000 megawatt reactor per year. The picture on the right is a fuel assembly. This slide shows the various type of reactors which are used for electricity generation. The first one is pressurized water reactor. Use pressure of the water to heat a secondary source of the water that generate electricity. The second one is boiling water reactor, that boils water, which is called as a coolant, which used as a coolant that makes steam to turn turbine. The third important reactor type is graphite moderated pressure tube boiling water reactor, similar to BWR but uses graphite and oxygen. The fourth one is Canadian deuterium uranium, doesn't use enriched fuel, has a lots of tubes and internal contamination issues. The fifth one is fast breeder high temperature gas reactor, uses uranium 235, uranium 238 and plutonium 239. The fifth one is advanced gas cooled reactor, also cooled with carbon dioxide or helium. The second type of nuclear reaction is called nuclear fusion reactions. The nuclear fusion reaction is the inverse of fission reaction. In nuclear fusion reaction, smaller nuclei or daughter nuclei combine together and form a larger nuclei with the emission of immense amount of energy. This slide shows the requirement for fusion reaction to occur. The particle must be hot enough. High temperature is required in sufficient number. It means that the concentration of the particle should be also high and well contained. It means that they should be confined in some specific place. So all these conditions are very difficult to achieve. However, these simultaneous conditions can be obtained by fourth state of matter, which is known as plasma. In plasma, the temperature up to several million degrees centigrade are reached. Therefore, no material object on the earth has the ability to survive in such high temperature condition. Therefore, it is difficult to use it for electricity generation. However, in the recent few decades, scientists has achieved some clues in which in the near future, they will be able to use the nuclear fusion reaction for electricity generation. The nuclear fusion reaction for warfare has been used from 1951 to 1962. The first nuclear fusion bomb or hydrogen bomb was detonated by the US in 1951, and the last fusion bomb, hydrogen bomb, was detonated by the USSR in 1962. The last fusion reaction bomb or the hydrogen bomb was detonated by USSR in 1962. After that, the nuclear tests were abandoned by signing a treaty by United States and the USSR. However, it is too difficult to use the nuclear fusion reaction for electricity generation. Thank you for your patience.